Hello, dear friend. Today we'll talk about how to analyze the spectrum of silver 3D XPS spectrum. The silver 3D with silver 3D5 and 3D3 spin orbital splitting around 6 electronvolt. It doesn't clearly distinguish between the metal state and the oxidized state because both binding energy of silver 3D5 are very close, generally around 368, you can see. In Advantage software, you can see one characteristic of pure silver peak. First, half peak wise is relatively narrow and it has an energy loss feature. However, I would like to remind you that when silver content is low, the loss peak will not distinct. Additionally, when both the metal and oxidized states are present, most of the time you cannot see the loss feature, just like this. And the peak width may also become broadened. At this point, it's difficult for you to determine the chemical state only by silver 3D. Let's take a look at the outer peak. The kinetic energy position of the characteristic outer peak, silver MNN, can be clearly distinguished. For silver metal, the outer kinetic energy is higher, while for oxidized silver, the kinetic energy is lower. Also, the peak's shape are quite different. Now, we introduce a concept called order parameter. The original definition of the order parameter is the difference between the kinetic energy of order electron and photoelectron. However, we usually use the sum of the photoelectrons' binding energy and the order kinetic energy as a modified order parameter to determine the chemical state. In XPS handbook, you can see the binding energy values of silver 3D5 for different chemical state, and the kinetic energy values of the outer peak. From this figure, for pure silver, you can see pure silver, it's generally around 358, while for oxidized, it differs by about 2 electronvolts, around 356. Therefore, we can judge the chemical state by combining the order and order parameter. This is a list of order parameters. You can see the values obtained from the sum of the binding energy of silver 3D5 and the kinetic energy of the outer peak for different chemical states. In our actual data, we must scan high resolution spectra of both silver 3D and outer peak. The scanning for this one is not so complete because we need to mirror the peak's kinetic energy value. In this way, by combining the order and the 3D peaks, we can judge the chemical state. Of course, if I determine that the silver exists in oxidized state, we can also check the oxygen peak to see if there's the presence of metal oxide. From this data, there's indeed 530 electrovolts, so indicating the existence of oxidized silver. Different peaks of elements combined together, verifying each other, can lead to a more accurate analysis. Thank you.